talk to you about the metric system, and this can be found in Chapter 8 of your material. This is the scale that I like to use. This helps me, it seems to be the simplest way for me to convert between the metric system. The base units for the metric system we use are the meter, which we measure length in. So if you've been used to having a yardstick in your past, a meter stick and a yardstick are almost the same thing. A meter stick is actually around 39 inches long, so it's a few inches longer than a yard. So anytime you see the unit meter in your mind, if you're more accustomed to using yards, you can think of that being very similar to a yard or yardstick. So we have the meter for measuring distances, lengths. Okay, the next basic unit we use is liter. Now, I think people are very accustomed to talking about liters now because of the pop industry. We're so used to buying pop in liters now. 2-liter bottles forever, people were buying the 2-liter bottles of pop. So we have a good frame of reference for what a liter looks like, I think. So that's our base unit for measuring volume or capacity for our liquids. And then the third unit we use is the gram. Now this one I have a little more trouble with because a gram is actually so tiny that you wouldn't feel it in your hand. The basic unit for what we would consider weight in the metric system is actually a very tiny unit that I have trouble wrapping my mind around. Actually, the better unit that you're probably more familiar with is a kilogram, because a kilogram is close to what we in the English system consider to be a pound. So kilograms and pounds, and sometimes they'll measure newborn babies, they'll weigh them in kilograms instead of pounds. So that's the closest unit probably for our frame of reference. But those are our base units, and then we add these prefixes onto them to change their value in units of 10. It's a real handy system because everything is based on tens, which means we'll only use our normal decimal notation is units of 10 anyway, and we just move our decimal point to change its value. So the prefixes that we'll mainly focus on for our use are deca. We don't use that one even that much, but deca is a DA abbreviation, and deci just has a D abbreviation. So if I say a DG, that means a decigram, or a tenth of a gram. If I see a DAG, that's a decagram, which means you have 10 grams multiplied by 10. Hecto is times 100, and kilo times 1,000. So 1,000 grams makes a kilogram, and that's how much it takes to really be able to weigh it. Think of it, frame of reference, similar to a pound. Still really light. Deciliter would be a tenth of a liter. Centiliter would be 100th of a liter, so we're dividing as we go down the scale, and then milli makes it real tiny, a thousandth of something, like a millimeter is a very, very tiny measure. You probably wouldn't even be able to detect that you moved a millimeter. Okay, so as I add these prefixes, like I said, we'll move the decimal point as we move from a lower unit up to a larger unit. As we go up the scale, we'll move our decimal point to the left, up, left. If we go down the scale, we'll move our decimal point to the right. So I like to think of the word, this is downright easy when you think about it. Down is right, up is left with the decimal point. Okay, so my first problem from the study guide, number 37, says to take 23.7 hectograms and convert that to grams. So we're going from hecto to grams. So find your spot on the scale. We're at hecto, and we're moving down to the base gram. So that's 1, 2 down, 2 down, down means right, 2 decimals right, so 1, 2. It adds a 0 to the end. Number 38, we're going to go from a liter to a milliliter. So again, we're going down the scale. Liter is here, the base units, and going down to milli, which is 1, 2, 3 places down. Again, down moves right, so 3 places. So from the decimal, which is right here assumed, 3 right adds 3 zeros to it, 39,000 milliliters. Also, I should mention that this scale is not, I told you I try to remember to tell you what to memorize for the final. This scale is not given on your Math Excel test, so you won't see this scale. So that means you do need to memorize this conversion. So definitely one of the things you need to memorize. Okay, number 39 says arrange these from smallest to largest. So we have these 3 units. They're all in different unit measurements. We have a milliliter, a hectoliter, and a kiloliter. without converting those all out to the same unit. So I would need to use my scale and make them all in the same unit. So I chose milliliter. You could have chosen any of the units, but they're easier to compare when they're all alike. So I'm going to leave 31,000 milliliters as is, and then I'm going to change the hectoliters, 0.27 hectoliters into milliliters. So to go from hecto to milli, that's a long move down. Hecto's up here to milli. That's 1, 2, 3, 4, 5 down. So that moves this decimal 5 right. So 2 places there, 3 more zeros, 27,000 milliliters. Then the kiloliters, again, I want to make it into milliliters. So from kilo, way up here down to milli, that's 1, 2, 3, 4, 5, 6 down, means 6 right. So 1, 2, 3, then 3 more places, makes 26,000 in milliliters. Now I can tell the smallest one, since they're all in like units, the smallest one is this one, 26,000 milliliters, or the 0.026 kiloliters. So that's the smallest. 27,000 milliliters will be next. This 27 hectoliters, that's the second. And then the 31,000, which looked like maybe the biggest one originally, but it is actually, it is actually the largest one, isn't it? So that one's, because we were going smallest to largest, sorry about that. So that one is actually the largest, and it looked like it might be as well. Okay, number 40. Number 40, we have a fish tank, and we're asked to find its measurement in, or its volume in cubic meters. It tells us that this fish tank is 5 meters long, 4.8 meters wide, and 66 meters tall. So pay attention because that one was given in a different unit, centimeters instead of meters. And then it asks us to find that volume. The volume is blank cubic meters. So cubic meters, because to find volume, you take the length times the width times the height. You multiply the 3 units. Again, volume of this tank would be length times width times height, multiplying the 3 dimensions. If it's going to come out in meters cubed, it needs to be meters times meters times meters, all like units to get cubic meters. So we need to convert this 66 centimeters into meters. So back to that scale again, very important scale. 66 centimeters is how many meters from the scale, going from centimeters up to meters. That's 2 up, finally going up the scale. All the other examples went down, but going up the scale means move your decimal to the left. So 2 places left, the decimal's assumed to be at the end when you don't see it, so 2 left makes it 0.66 in meters. So then I multiply 5, use your calculator, times 4.8 times 0.66 will come out in cubic meters, and I have a note that that comes out to be 15.84 in cubic meters. Okay, number 41. I want you to notice in the next couple of problems, this is important detail about using the chart. Now, I did mention this earlier, but when you're using the chart and only moving one place per one move, that's when you're in linear measurements. If it's just regular meters, regular liters, just regular units to the first power, you move one place for every move on the scale. When we move to number 41, we're talking about square centimeters and square millimeters. Now we're moving 2 jumps. For every move on the scale, we move our decimal twice because it's 2-dimensional now. So we've got a length and a width that's affecting it. So it's by 2 units, by 2 decimal places. So when we go from square centimeters to square millimeters, we're talking about the centa back to the scale. The centa down to milli is only 1 move, but we move 2 decimal places. And again, it's down, centa to milli is down, so we'll move right, but we'll move 2 places with our decimal point. So from the decimal point assumed to be at the end, 2 places over adds 2 zeros to it, so it's 48100 for that answer. Okay, then number 42, we take it even up another notch. It's cubic meters to cubic decimeters. So we're moving 3 places because it's 3-dimensional. Like the cubic meter problem we just did on the fish tank, it had 3 dimensions. So we're moving 10 by 10s for each dimension, by the length, the width, and the height. So it's 3-dimensional, so it's 3 decimal places for every move on the scale. So from meter to decimeter on the scale is only 2 moves, but times 3 for each place. We're moving 6 decimal places. From the decimal, understood to be at the end, 6 places over actually adds 6 zeros to this one. It makes it 5 million. So 5 million cubic decimeters. Okay, number 43. Now this is totally different. We're going from a liter, which looks like a linear unit, to a cubic centimeter. And that's because they're not both considered to be in liquid measure. You know, a liter is liquid, like our liter of pop, and cubic centimeter we think in more solid terms. But, and this is more reading can be found in the book, it is true that if you, and I don't know that I'll say the exact rule right, you'll want to refer to your book, but if you take some sort of container that is 1 decimeter wide, long, and high, a cubic decimeter container, and pour water at a certain temperature, there's a certain rule you have to follow. But anyway, the liquid that would fit into a cubic decimeter is 1 liter. So those are the like units that we can use to convert between liquid measure to cubic solid measure. But anyway, this is the conversion. You do need to be familiar with this for your test as well. A liter, and I think that if you think about it a little bit, you can get a visual for your liter of pop and know that a cubic centimeter would be way too little. You wouldn't be happy with that drink of pop. A centimeter is very tiny, like an inch. An inch by inch by inch would not be a liter of pop. And I think you would realize that. And of course, millimeter is too small. But decimeter, that's pretty good. Decimeter would be 10 of those centimeters. So you go out a decimeter each way, and now we're talking about what we normally think of as a pop. Meter wouldn't make sense. You know, a meter stick, if you had pop from there to there, that'd be a big box. That's way too much. So I think that if you think about it a little bit, decimeter is the only reasonable unit that would work for this. So liter and cubic decimeter go together. All right, so now I'm ready to try to convert this thing. So I've got 15.2 liters, and I'm trying to get into cubic centimeters. Well, cubic centimeters isn't the one I need. I'm going to convert it to cubic centimeters, but first of all, I have to take the jump to this conversion of cubic decimeters. So 15.2 liters would be the same as 15.2 cubic decimeters. Those are the same. Now take the jump to cubic centimeters that we're asked to go. So cubic decimeters to cubic centimeters. Now we're talking about our scale. Deci to centi is 1 move down on the scale, but because it's cubic, we move by 3 decimal places. So down is right, so 3 places over, and finally we have it converted out to cubic centimeters. Okay, number 44, 44 and 45 is using your Celsius scale. Now I will tell you on the test that this formula is given, so you won't have to memorize the Fahrenheit Celsius formula. So on number 44 it says convert 15 Celsius into Fahrenheit. So you drop that 15 into C, 15 Celsius, and solve that equation. 9/5 times 15, you can do this on your calculator. Those, a lot of things, do it by hand, you would have the quicker way to punch that in. So that would multiply to be 27 plus 32, which is 59. So that should be 59 degrees in Fahrenheit. 45, we go the opposite direction. Now, if you notice on your study guide, this formula was not given, but the one that you have, you will have a formula given. Celsius is 5/9 times Fahrenheit minus 32. So we're going to plug in the 120 for F for the Fahrenheit, and then do your parentheses first and multiply by 5/9, and you should come out with a conversion into Celsius. So we'll stop there with the metric system.